So now we can do what's called the law of sines. Right? The law of sines. So there's two laws, right? The law of sines and the law of cosines. They're both used to solve oblique triangles. Oblique means it's not a right triangle. Right? We've got all of our ways to solve right triangles. Now we need some ways, what if it's not a right triangle? And that's what the law of sines and cosines does for us. Now, under some conditions, it depends like which parts of the triangle that you've been given, right? Which sides and angles do you know? And this is very familiar to, geometry days when you used to prove two different triangles were congruent, right? You would say like side angle side, side side side, right? So these are the circumstances using those same kind of terms when you use the law of sines and when you use the law of cosines. So you use the law of sines if you've got angle, side angle. Means you've got two angles and you've got the side that connects them, what you call the included side, right? Or if you've got angle, angle, side, meaning you've got two angles in a row and you've got a side which is not the included side. Or if you've got side and then a side and then an angle. Those are the three that you use law of sines. Okay, next class we'll do law of cosines, and then that's side, 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 angle, side. Okay, that's good. So I'm back up here. So the law of sines. You start with a triangle that's labeled like we learned last class, right? A capital A is the angle A, and the side across from it is the lowercase letter a, right? For A, B, and C. This time the C can be anything, right? With a right triangle, C is always the right angle, but with this one, you probably don't have a right angle. So the law of sines says that the sine of A divided by side A equals the sine of B divided by sine B equals the sine of C divided by side C, right? Now you're not using all three of those at one time. You'd be taking like one part of it, like either you're solving this, right? Or you're solving this. Or you're solving this equals this, right? In the end, you're just going to have two sides to the equation. Now, this is a law. I mean, even though we don't need right triangle trigonometry anymore, in fact, you could prove this one fairly easily with the math that you know by doing this. Let's say that I make an altitude of this triangle, right? What is an altitude of a triangle? Right? It's that side right there, right? It's a perpendicular line that goes from the vertex to the opposite base, right? That's a right angle. And then I'm going to call that H for height. Okay, so now I could say that the sine of A equals H over C. Sine of the angle A, this is just right triangle trigonometry, is H over C. That means that H equals C times the sine of A. Okay, well I can do the same thing with angle C. The sine of angle C is going to be H over A. So H equals A sine C. Okay, now since H equals C sine A and H equals A sine C, I can make an equation out of those two. C sine A equals A times the sine of C. And now if I divide both sides by AC, I get sine A over A equals sine C over C. The law of cosine is a little harder to do, but the law of sines actually doesn't take that much to figure out where that came from. Right? So when we're solving triangles using the law of sines, if the thing you're looking for is an angle, then using the law of sines, like I've got it written there, is useful because it's got the angles are all in the numerator. But if the thing you're trying to solve for is the side, you could make an alternate version of this and instead just flip all those fractions. You could say A over sine A equals B over sine B equals C over sine C. I mean, you don't have to, but I will always use the one that keeps my variable in the numerator because it just makes it easier for solving. Good. Okay. That looks good. I think so. Back up here. So here's an example solving. Okay, so C equals 107. That's here. B is 25. And little b is 15. Now, what you can see from the law of sines is that you need to know, in order to use the law of sines, you need to know one angle and opposite side pair, right? And so in this problem here, you've got angle B aside from side B. So, we would use that part of it. We're going to solve for side C first because that's across from angle C. So I would be using this. C over the sine of C equals B over the sine of B. Right, and then I can fill in C over the sine of 107 equals 15 over the sine of 25. Okay, solve for C. C is going to equal 15 times the sine of 107 divided by the sine of 25. And that you could put in the calculator. Where's my hover cam? There. Okay, so 15. Make sure you're in the right mode. Remember, go to the mode key. I'm not. I'm in radian. So let me go down, hit it to degree, then 15 sine 107. Make sure to close the parentheses before you divide. Sine 25. And it looks like 33.9. And let's just say, let's use to the 10th. Okay, so we've got that one, 33.9. Now, can I use Pythagorean theorem to find the third side? No, because it's not a right triangle, right? So we're going to have to do another law of sines to find side A. Okay, but if I'm going to find side A, I need to know angle A first. How can I fill in the angle A? Yeah, just subtract from 180, right? Did you already do it? Would it? 48. Yeah, we don't need trig for that. Just subtract 180 minus 25 minus 107. Okay, now set up the A. This is going to be A divided by the sine of 48 equals 15 over the sine of 25. Right, solve for A. A equals 15 sine 48 over sine 25. So let's do that. 15 sine 48 end parentheses divide by sine 25. 26.4. So that is solved. Right? We found all the missing sides and angles. Again, the key to using the law of sines is you got to have one side and opposite angle pair, and then you can find missing parts. So try this one as a you try. Get it? That one's right. That one's not right. That is correct. Do you have the other one? Yeah, that's right. I think that's actually 7.7. So, right. So in this one, when you filled in the information, right, you knew A and B, and you knew side C, but you didn't have one side and angle opposite that you knew, right? So you had to like right away do the 180 minus to get that one, right? That's why in the end, at the angle side angle and the angle side are pretty much the same, because if you've got 2 out of the 3 angles, you can always just fill in the third one, and now you have to have one side and opposite angle pair, right? So this was the angle side angle, and we found that. And then so we were able to use that pair on the right-hand side, and I solved for A first. A over the sine of 51 equals 11 over the sine of 85. I got 8.6. Okay, and then I do the same thing for the B. B over the sine of 44. So the 2 answers right there. Make sure I'm recording so I don't make a mistake like last time. Okay, so here we go. Now, when it comes to the side-side angle, this is the one that's actually the most complicated, because there's 3 possibilities when you get a side-side angle. It's possible that there's no solution. So first, just to kind of orient us what we're looking at here. If it's side-side angle, it means you've been given the lengths of 2 sides, and you've been given the measure of an angle, which is not the included angle between those 2. So this is always the way we set this up to look at it. So here's the 2 given sides, and this is the angle that's not included. Now it's a dashed line because I really don't know how long that line is. I just know that it opens up that far. Now, if they give us, if they give you this side, and then this side is like not long enough to reach to the other side of the angle, then it's not going to be a triangle. Again, if I would put the altitude in here, if I would calculate the altitude, which I could do fairly easily, if I know this angle and this side, I could calculate what that is. And if I've been given the second side is shorter than the altitude, that means it's not going to reach to the bottom. So we'll see how that looks when you start to solve it. What does that look like? Okay, so if there's no solution, it's because that second side is just not long enough to to make a triangle, because it doesn't reach all the way to the bottom. Right? That's one possibility. Next possibility is that there could be 2 solutions. Meaning that, with the given angle, this is the same, and this first side, this is the same. This side here could be longer than the altitude, so it is long enough to reach that other side, but it's actually shorter than the first side. So by having this side reach there, that's one triangle, right? But that same length, if I would just like pendulum it over to there, it would actually make another triangle. It's still the same length of the side, but what it means is that you've got 2 possibilities, right? You've got one which gives you an acute angle at that corner, and then if actually it connects over here, then that's an obtuse angle. So you're going to get 2 possibilities. That's called the ambiguous case, right? Because there's 2 possibilities for it. Again, if you wanted to do it like really mathematically, you would say this side is less, it's more than the altitude, but it's less than the first side. But I usually don't calculate that. I just like start to solve it, and you'll see how it becomes apparent that it is that case. Right. Then the last possibility is that actually that second side, it's long enough to reach to the other side of the angle, right? And it's actually longer than this side here. So there's no way you could like swing it back over this way and make a triangle into this space, right? Because it's just too long. So those are the three possibilities. Either you got no solution, you got two solutions, or you got one solution. You got no triangles, you got two triangles, or you got one triangle. Okay, now we're going to see like, what does that look like when you're solving? How does that become apparent? Okay, so solve this triangle. A is 115, so let me mark that. Little a is 20, and B is 11. So that's a side, and an angle. Okay, now when we solve, like I said, we don't know what we're going for here. Is this going to be two triangles? Is it going to be one triangle? Is it going to be no triangles? But you could see that the angle that you've already been given is an obtuse angle. Is there some way that we could get another obtuse angle in the same triangle? No, I mean, you can't have them add up to 180. That wouldn't work, right? So we can be sure in this case that we're not going to end up with two triangles because there's no way to get another obtuse angle out of this. So let's just go ahead and solve it like we would. Let's see, we have our opposite side and angle pair. So we need to use that. And we've got one side here. And so we'll have to solve for angle B first. So I'm going to use that form of the law of sines where the angle's in the numerator. Sine of B divided by 11 equals the sine of 115 divided by 20. So the sine of B equals 11 times the sine of 115 divided by 20. Okay, let me do that. Turn it on. Okay, so I'm gonna put this in. You might want to watch how I'm doing this because some questions came up in 1A and they actually learned something here. So 11 times the sine of 115, right, in parentheses, divided by 20. Okay, so when I'm writing these down, I'm going to write down 4 decimals, so 0.4985, 0.4985, 0.4985. Now that's not angle B, that's the sine of B. Again, how do you find B? How do you solve for the angle when it's inside the trig function? You do an inverse, right? So you're going to have to say that the B equals the sine inverse of 0.4985. Now, I just rounded that off to 4, right? But remember, in the calculator, you can do this. If you've never seen this before, right? I'm going to go second sine inverse, right? And then I'm going to go second the negative sign down here, right? That brings up the last answer, which is 0.4986, blah, blah, blah. So I don't actually have to like write down decimal places or anything, you know, I'm actually putting the whole thing in there when I do that. Now when I hit enter, it gives me the angle, 29.9 degrees. Okay, so that was our B, 29.9. Okay, now we need to find angle C. So let's do our 180. 180 minus 29.9 minus 115. 35.1. Okay, now that we know angle C, we can go across and find side C. So let's use the law of sines where we've got the C, side C in the numerator. C divided by the sine of 35.1 equals, and I'm just going to use the same one I used before, 20 over the sine of 115. Right? Therefore, C equals 20 times the sine of 35.1 divided by the sine of 115. $12.7. So that was 12.7. So that was one triangle. You know, we know there's not two again because we've already got one obtuse angle. There's no way we would get another obtuse angle out of this. Okay. Let's try that one. See if you could solve that one. And again, it's going to be, you could see there's an obtuse angle already in it. So this is just going to be a 1. Okay. So now you got to multiply that up there. Did you already do it? That's the wrong value. I'll check that again. You said it was 18. Right? 18 times the sine of 23. Yeah, you put in 12. Did it? That is correct. That is correct. Good. That is good. So you don't put it in. That looks good. Okay. So again, you set it up, fill in the ones that they've given you. It looks like we had to solve for the angle B first. Should have got the B of 34.4. Subtract from 180 to get 23.6. Solve for side C, 8.5. Okay. Now, I'm going to solve this one. And you'll see what happens here. Okay, 51 degrees. So this is an acute angle. A is 3.5 and B is 5. So again, I'm going to set this up to solve for angle B. The sine of B divided by 5 equals the sine of 51 divided by 3.5. Okay, so the sine of B equals 5 times the sine of 51 divided by 3.5. Sine B equals, okay, let's do all that. 5 sine 51 divided by 3.5. 1.102. 1102. Okay, now, again, how do I solve for b when b is inside of the, I got to do sine inverse. So I go second sine, second negative sign to bring up my last answer, and then I get an error. Right? I got an error. So what's going on? Why would I get an error when I tried to find the sine inverse? Because sine has to be between -1 and 1, right? We know from the unit circle that it never gets to be more than 1 or less than -1. So you can't take the sine inverse of 1.1102. That's what it looks like when there's no triangle, right? You're going to solve for an angle and you're going to get something like that where it's, you know, the sine equals something more than 1 or less than -1. So you're going to have to say no triangle. No triangle because sine is less than or equal to 1. Okay. Okay, now let's try this one. 40 degrees goes here, 13 and 16. And again, I'm going to go through the same process, right? I'm going to go that the sine of, the sine of b divided by 16 equals the sine of 40 divided by 13. So the sine of b equals 16 times the sine of 40 divided by 13. Sine b equals 16 sine 40 in parentheses divided by 13. 7911.7911. Okay, and so that b equals 52.3. So now this is what happens when you're solving these things, and you got to check to see whether or not this could be the ambiguous case where there's actually two triangles, right? You look at this 52.3, right? If I put 52.3, that's one possibility. I could say that would be the acute angle. That's the one like I showed a few slides ago. Let me go back to it. That's this one right here, right? The angle that we found is acute, less than 90 degrees. But what if we could also have an obtuse angle, right? Well, this is how you figure that one out. Remember, what does the sine, and the unit circle, what does the sine equal? What does that represent? It's the y coordinate, right? So if I'm looking at on the unit circle here, 52.3 is about right there. So what we're saying is the sine of our angle right there is 0.7911. That's how that distance, you know, from the x-axis up to that point, right? But sine could also have the same value if I just go straight into the second quadrant right there. That's also exactly the same distance above the x-axis. So I need to check and see whether that angle could possibly make a triangle, right? Okay, well, if this angle is 52.3, then this angle should be 180 minus 52.3, right? I'm going to go up from 180. So what is 180 minus 52.3? Say again? No. 127.7? 127.7. Okay, so I'm going to go to the next slide and say, what if instead of 52.3, this is 127.7? Well, the other angle that I know is 40. Is it possible to have a 127.7? And the only reason it wouldn't be possible is if these two already add up to more than 180, then there can't be another triangle. But do they add up to more than 180? No, they don't. So in fact, this can be another solution. Sine would have had the same value in the second quadrant with an obtuse angle. So we're going to have to do this twice, right? The first time we do it, we're going to use the 52.3. And the second time we do it, we're going to use 127.7. And then you got to find the missing sides and angles. So let's go back to the first one here and finish this one out. Okay, I'm going to erase this here so I got more space. Okay, so we got the 52.3. We need to subtract from 180 to find that one. Right, 180 minus 52.3 minus 40. $87.7. Okay, we still need to find side C. So C divided by the sine of 87.7 equals 13 over the sine of 40. So C equals 13 times the sine of 87.7 divided by the sine of 40. $20.2. So 20.2. Now, if you're ever suspicious of your numbers, like you're not sure you're getting your numbers right here, you could always do the check that you would do in geometry, like, is the biggest side across from the biggest angle? Is the smallest side across from the smallest angle? Because sometimes, if it's not, you did something wrong. Like, am I okay in this case? It looks like the biggest angle is 87.7 and the biggest side is 20.2. So that works. The smallest angle is 14 and the smallest side is 13. I mean, that's not a guarantee, but that is, at least you could catch a mistake if it wasn't so, right? Okay, now we need to go to the next one. Right, we got the 127.7. I can still fill in the A was 13, the B was 16. I need to do the 180 minus 127.7 minus 40. And now it's going to be 12.3. Okay, and so the only thing we need to fill in is the C. So C divided by the sine of 12.3 equals 13 divided by the sine of 40. So C equals 13 times the sine of 12.3 divided by the sine of 40. That look right? 4.3. So 4.3. And now again, let's check. The biggest angle, 127.7, is across from the biggest side, 16. The smallest angle, 12.3, is across from the smallest side, 4.3. So it fits that. So again, when you're solving, and you got to figure, is there two solutions here? you're going to get to this point where you figured out that first angle, which will always be acute. When you do a sine inverse, it never tells you an obtuse angle. It will always tell you an acute angle. You've got to be the one that then it says, okay, but would it fit, if I did 180 minus that, would it still fit in that triangle? You know, leave me some value less than 180 so the third angle would be positive. That's the check. So try this. So you don't have to solve both triangles, but see if you could find both values for angle B. This is going to be one of those, right? If you try. That should have been 51.6. Either one is fine. Either 180 minus that. Right. Yeah, see, if that was, what is it, 128.4, and that angle was still 36. If you add those two together, are they less than 180? Okay, then, yeah, that's it. Get ready? Yeah. How about you? That's the right first, that's the right first one. All right. So, I mean, I added that later, but, you know, just solve for B, you would have got 51.6. Right? And then you check, okay, if 180 minus 51.6 is 128.4. If I put that up there, 128.4, and I add these two together, is it less than 180? It is, so this could be a second triangle. So those are the two possibilities. It's either 51.6 or 128.4. Good, Olivia? Okay. You good? Okay. So here's another thing that comes up with the law of sines, is that there's actually a formula for the area of a triangle, which is not the one you already know from geometry. Right? We know from geometry that the area of a triangle is 1/2 the base times the height. Okay, but normally when you got a triangle, you don't necessarily know the height. So kind of similar to what we did before when we developed the law of sines, if I made a height, an altitude, going right through the middle of this here, I could say that the sine of A is h over c. Sine A equals h over c. Solve that for h. You're going to get c times the sine of A. So in place of the h in this formula right here, we can place c times the sine of A, which gives us a new formula, or instead of 1/2 BH, it's 1/2 B times C times the sine of A. So I'm not going to leave it on that because you don't need that as much. The next slide, I'll put it all together. So in fact, that's this one right here, right? But all it really needs, you need to have two sides in the triangle and the included angle, right? B, C are two sides and A is the angle that connects them, right? Or A and C are two sides and B is the angle that connects them. As long as you know side, angle, side in a triangle, then you can use this formula to find the area. So now we're going to do a problem, right? So this is from the book. Guys, Jason, you need to move back? Okay. Black-necked stilts are birds that live throughout Florida and surrounding areas, but breed mostly in the triangular region shown on the map. Find the area of this region. So notice that they've given us on here, they actually have labeled the vertices A, B, and C, but you don't really need that. You could see that there's two sides and the angle that connects them, the included angle. So we need to use that, right? We're going to say the area of that triangle is 1/2. I think that says 223. 223 times 125 times the sine of the angle between looks like 54.2 degrees. So area equals, and we can put this in our calculator. .5 times 223 times 125 sine 54.2. 11,304.2. And what was that in miles? Miles, so that's miles squared. So it's fairly easy formula to use. You know, try this one. This is your you try. Find the area of that triangle. That should have been 50.4. Right? When you labeled it all, you had side, angle, side. Right? That's what you need. Two sides and the included angle. Plug it in, plug and chug, as they say. That's it. So now, on the homework here, right, there's these 5 problems here are one each. Okay, there's one angle, side, angle. There's one angle, angle, side. There's 3 of the side, side angles, right? There's one with 0, one with 1, and one with 2 triangles. So you'll know, like, if you've already got the no solution one, you're not getting another no solution one. Or if you already got the 2 triangle one, you don't need to worry about another 2 triangle one, right? And these 2 are the area, like we just did, and these are 2 word problems. So they're just one of each kind.